Okay, so we were on break last week for Labor Day, and so we are doing week 5 this week. And I wanted to go ahead and give you guys a heads up that it's my intention only to record through next week, which is week 6. The Math Map is an awesome curriculum that our family enjoys, and my intention with these videos has been to give you guys an example of what using the curriculum in our home has looked like, especially with a variety of domains and ages. But because classical education really does lean into the dialectic conversations with your students and away from the scripted dialogue, the intent behind these videos has always been for modeling and not necessarily for teaching. So we are about to start week 5, which is multiplication. This is our day 2. So we're going to jump into, actually before we get started, let's do the game today. Y'all flip over on the back side and we have our multiplication table. And it is, so let's see. Okay, so let me get a deck of cards real quick.
1, 2, 3.
Right. And the way that this game is going to work is that I will draw a card, and we are going to choose a family number, and then as I pull, Dad just arrived home, as I pull the cards, we're going to follow that family and multiply it by the number on the card that I have drawn. So, goodness, these are all mixed up. Okay, so let's practice. This week we're doing 5s and 6s. Let's go ahead and practice with 5, since that is going to be an easy one to follow. Everybody on the back, do you see the row of 5s right here? So whenever I draw a card, for example 3, we're going to say 5 times 1, 2, 3 equals what?
15.
Good, so 5 times 3 equals 15.
5 times 3 equals 15.
Good, what's this one?
2 times 2. 2
5
times 5
equals 10. Susie, here you found the 5. Here you found the 5. Here you found the 2, and you follow those 2, and then it matches, or it meets at that grid. All right, what's 5 times 5?
5 times 5 is 25.
All right, let's take turns. Mason, what's 5 times 10? Where do they meet? Yeah.
15.
Not 15.
15.
50. Good. Libby, what's 5 times 9?
5 times 9 is 45.
45. Good job. David, what is 5 times 6?
5 times 6 is 30.
30. Good job. Ayla, 5 times 3.
5 times 3 equals 15.
All right, let's try it with 6s. So now we're going to go to the row 6. You ready? What is 6 times 8, Mason? So we're going to follow 6 and 8.
84.
Try again. Flip those.
48.
Good. I'm getting some rulers to help y'all kind of track a little bit better. You're doing a great job, but this will probably make it a little bit easier if you want it. Okay, whose turn? Is it Libby's?
Yeah.
6 times 8.
6 times 8 is 20.
Very good. David?
6
Times 4.
4 is 24.
Good job.
6 times 3 equals 18.
Good. Mason?
10 times 6 is
times 7 is 42.
Good. David?
6 times 9 is 48.
6 times 9
I know.
is 4. 54. Good. Okay. Let's switch to the threes. Ayla. 3 times 6.
3 times 6 equals 18.
Mason. 3 times 7.
3 times 7 is 12.
No.
Wait, here?
No. This one's 12. What's this one? 21. 21. Good deal. Gotta love the dyslexia, huh? All right, Libby. 3 times 5. You're doing great, bud.
3 times 5 is 15.
Good.
You can also do it up and down.
Yes, you
That
can.
counts out for 15.
No, that's not right on it. David, 3 times 2.
3 times 2
If I can find the shop tickets, we can stick the whole thing in the shop ticket and use right on light bulb later, but not right now.
is
6.
And Ayla, 3 times 2.
3 times 2 equals 2.
All right, now go ahead and open up to I3 for me, please.
There. Nope, I4. Guys, I3 is this one. I flipped right to it.
No, you didn't. Right. All right. So, I3, our memoria and arrangement. So, who remembers what the digits used in a multiplication sentence or equation are called? Remember, we talked about how when we have our math fact written out like this, there are special names, Libby, for each piece of the equation. What were these two pieces called? Do you remember? Started with an F? Yes, factors. Factors. And Ayla, what's the answer called? That's for addition. What's it called for multiplication?
At the very beginning.
Okay. It's called a product. Okay?
Product.
For multiplication, we have factor, factor, product, right?
What's the middle?
Let me check myself.
What's the
Yep,
middle?
factor, factor, product. Okay, so, well, these are both called factors. So the ones, Libby, on the left-hand side of the equation are both factors, and this one's product. Just like in addition, they're both add-ins, and then it's sum for addition. Okay, so up here at the top of I3, we see that in order to add 5 out of 12 pieces, plus 3 out of 16 pieces, plus 2 out of 9 pieces, we have to have, can we add those? No, because they all have different denominators, right? We have to find our least common denominator, and we have to make them all have the same bottom number before we can add or subtract. That'll come later, but it's good things to know right now. All right. The flashcards were the game instead. Thank you. Okay, so in order to find
No.
our in order to find our factor represents the domain we're in, integers. Z means integers, okay? Mason, can you read our operation? You're right, it doesn't, hold on, pause, this is a fun fact. You ready for this? You're right, integers does not start with Z. The reason Z is the letter assigned to integers is because the mathematician who is credited with a lot of the credit for working with the integer domain, his last name started with Z. He was German. So he gets to use the first letter of his last name to represent integers because of how much work he did in this domain. Isn't that kind of cool?
He wrote this.
He did not specifically write this book, but he worked on a lot of the foundational concepts that are used in mathematics, specifically regarding integers.
Oh.
Okay, so Z means integer, yes? Mason, go ahead and read our operation.
4 times 4 is
Equals.
equals
16.
16,
16.
right? And our range is natural. So go ahead and trace that for me. What does the N mean?
No, natural.
Naturals, good. Yes, you can go ahead. Read that operation for me. Negative.
Negative 1 times negative 1 equals 1.
Very good. Why do, if we have two negatives, why is our answer not negative?
Is it equal 1?
Because two negatives makes positive, right?
Yeah.
All right, trace your number line with your hops. And why are we going to the left with our hops?
To get to 90.
Because what are we multiplying?
Ones.
What symbol is that? Negative, right? So we're doing 3 times negative 30 equals what?
Negative 9.
Negative 90. So we're going to the left because we're dealing with negatives, right? And what
Is this
domain does the
reals?
R equal? Very good, reals. All right, go ahead and trace your vertical hops.
What was this last name?
I would have to look it up. I knew over the summer, but I don't remember his last name off the top of my head right now. I do remember it started
Or you
with a
just
Z.
have it somewhere in your head.
I have it somewhere in my head. Now look at this real quick for me. What do we notice? Let's attend. What do we notice about this number line and this number line?
One's going
This one's
down,
going
one's
down.
Ah, so math is the same whether we're doing it up or down or left or right? Yeah.
It still goes to 90, but this one just has an I.
They're
And
both
the minus, and this just has a.
they're both 3 times negative 30. But one's vertical and one's horizontal, right? All right, let's vertical means up and down. All right, let's look at our laws. The commutative law for multiplication states, we're going to trace our dominoes. A times B. Dice. My
The twos
apologies.
are down.
Very good. Commutative law states A times B equals B times A. Remember, letters are just substituted for numbers, like you substitute the numbers in for the letters. So in this case, A is 5, and B is 4. And does it matter which one comes first?
No.
Nope, the commutative law means that they're the same, right?
Because you can show if A.
And our associative law for multiplication goes something like this. A times open in parentheses, B times C close parentheses equals open parentheses, A times B close parentheses times C. You remember that one? It's usually at the very end of the year. All right. Our identity law. What is identity?
Like, your.
It's who you are, right? It's yourself, right? So the identity law is what we do to keep the original number the same. So what is our identity law for multiplication?
Identity law for addition.
Is for identity law for multiplication 5 in this first one. Which one's on top?
5.
And what's on bottom?
1.
Now look at the next one. What's on top?
It's 1. Then 5.
Oh, so what do we think inverse means? Are they the same?
No. Yeah.
Yes,
But
but
they're
they're
not
in
quite the
different
same.
orders.
They're opposites, right? They switched places because the 5 started on top with the 1 on bottom, and then they were opposite and they traded places, and the 1 went on top and the 5 was on bottom, right? They're the same numbers, but they're in opposite places, right? So that is what inverse means. It means opposite. All right, multiply and trace. What is 2 times 6 meters? What is it equal to?
2 times 6.
8 meters.
Nope, that would be plus 2 groups of 6. Let's skip that.
12 meters.
6, 12. Good job. 6 times 12. I'm sorry, 6 times 2 equals 12. So 2 times 6 meters equals 12 meters. Which is larger, 12 meters or 6 meters?
12.
Yes. All right, circle the height. Is a mountain approximately 1 mile high or 1 foot high?
1 mile.
Yes. Is a barn approximately 10 centimeters or 10 meters?
10 centimeters.
This is 10 centimeters.
10 meters.
Yeah, this is a meter. Is it about 10 of these tall?
Yeah.
Yeah. A barn is about 10
Which one does it
meters. So centimeters is cm and meters is just m.
I think it would be.
Is a barn 10 centimeters or is it 10 meters? cm is centimeters. You want to circle meters, which is just m. All right. Is a daisy flower about 5 centimeters or about 5 meters?
5 meters.
5
This
centimeters.
is 1 meter. Is a daisy 5 of these?
They could be if you don't cut them.
If you live in Alice in Wonderland, maybe. Just the flower, not the stem.
Oh,
Yeah, just the petals.
the top one.
Yes, 5 centimeters. So we're going to circle centimeters as cm. Centimeters. All right, trace your number line for me. And who wants
Why
to
is
read
it
it?
called a number line?
Because
Has numbers,
line
but it
has
also
numbers.
has letters.
You're right. So the equation or the operation has letters, but the number line only has numbers. The line only has numbers. Who wants to read it for me?
Me,
How do we read it?
2, open parentheses, 5, close parentheses.
Pause. That is beautiful. That is the correct symbol. Do you remember what operation parentheses reminds us to use?
No.
Is it addition, subtraction, multiplication, or division?
I should have.
Multiplication.
Yes. You remember we talked about 3 ways to show multiplication. We can use the x, we can use parentheses, or we can use the radix point, right? So this is going to be read 2 times 5. Can you
2
read that?
times 5 is less than A. A is less than 6
Times.
times 5.
Good job. All right. So next, let's look at our multiplication section. 0 times 15 equals 0, right? Because anything times 0 is 0.
Why is there an M?
Meters. They're telling you what unit you're talking about. So 1 times 15 equals what? Because we talked about 1.
15 meters.
Yes, 15 meters. So here we're paying attention to, we don't have to figure out the numbers. They already told us the answer for the numbers, but we want to pay attention to the fact that our unit is staying the same, right? So we're going to copy our unit all the way down.
Try to try M.
1 times 15 meters equals 15.
M.
Yep, meters. 2 times 15 meters equals,
M.
no, it doesn't equal just m. How many meters?
15.
Read the number and then the unit.
15 meters.
30 meters. So 2 times 15 meters equals 30 meters. What about 3 times 15 meters equals?
45 meters.
Yep, Imaginary numbers. I had to think the word. Multiply i's. Go ahead and trace that right there. We have I to the first power equals the square root of negative 1.
I to the second power equals
Negative 1.
negative 1.
I to the third power equals what, Mason?
He
Do we
doesn't
trace
just one.
it?
Negative square root of negative 1.
1.
And I to the fourth power equals just 1. Right? Ooh, this is a fun one. Do you see a new symbol that we haven't used before here?
Exclamation point.
The exclamation point. So in English, it's called exclamation point.
We have
In
it right there.
math, it is called factorial. Okay? Factorial means that whatever number comes in front of it, you multiply all of those numbers. So for 3, you would multiply 1 times 2 times 3. Okay? So you are going to expand, or I guess they count down. So it would be 3 times 2 times 1. Okay, so we are going to complete our factorial patterns. So 2 factorial is the same as 2 times 1. 3 factorial equals what? 3 times, we have to count backward. What comes before 3? 2. 2. What comes before 2? 1. Good. So they already have the 3, bud. They already have the 3 written there, so you're just going to write 2 and then 1. Okay? Excuse me. All right, what's 4 factorial? It's the same as 4 times 3 times 2 times 1. We're on the next one already. Can you catch it? 4 factorial is 4 times...
What?
Nope, you got to count backward. 4, what comes before 4?
3.
Yep. Times, what comes before 3?
2.
Good. What comes before 2? Alright, do the last one. 5 factorial is equal to 5 times 4 times...
2.
Alright, says color and multiply. So here we go. What are the digits in a multiplication problem called?
The digit.
The factors, right? Okay, so we have factor times factor equals product. So our first one says 4 times how many?
2.
Color your 2. And 4 times 2 equals how many? Good job. Color your product.
Mom, is this the same problem?
Technically, yes.
Because I already used
Yes.
it. Here.
Equals, no. So this is showing you the blocks, and then your product written is over here. So then on the next one, you're going to say, what number is this?
5 times 2
Equals, how many is that?
15.
10. And you'll write that in that blank.
Mason, that's not what you're supposed to be coloring.
All right, get your pencil. 5 times what?
2.
5 times 2 equals how many?
1, 2, 3, 4,
10. So you're going to write that there. Okay, and then what's this last one?
6
6
times 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12.
Good? Not 21. Switch those. You need to answer it. So 5 times 2 equals how many?
65.
No. How many units do you have? Stop helping.
10.
10. And 6 times 2 equals how many? Not 21. There you go. Good. All right. Turn the page.
That's what I was going to do.
Good deal.
I do mine too fast because it feels better.
Oh.
I've been here.
So we're looking at some weather. What does our weather look like?
Oh,
close to the green. We're close to the one.
Yes, we're working our way that way. Alright, looking under our two skiing kiddos, we have 4 times 0 degrees Celsius equals how many degrees Celsius? 4 times 0 equals?
4 times 0.
0. Anything times 0 is 0. So we have 0 degrees Celsius. And then 2 times 16.
Equals 18.
Ooh, not 18. That would be plus. We're multiplying. Our multiplication table only goes up to 15. So
2 times
16. So you can do 2 and 15 is what? There is no 16, but here's what I'm going to show you. What's 2 times 15?
50.
No. 2
45.
and 15. What number is this?
55.
What number is the one that I'm pointing at?
30.
30. Okay, so if 2 times 15 equals 30, and we need one more group of 15 to get to 16, right? So what's 30 plus one more group of 2? Let's do it this way. Vertical. Alright. 0 plus 2. Let's keep our 1 straight. What's 0 plus 2? 2. You said it. 2. 0 plus 2. What's 3 plus 0? 3. So, 32. Because 2 times 15 is 30, and then we add one more group of 2 to be that 16th group. Right?
Can I do my number line?
And your answer is going to be 32. Yes, you can do your number line.
A is
Hold on, you read the last one. Let's let somebody else have a turn.
A is greater than 5 plus times 14.
14.
14.
Good. Libby, can you read the second one?
B
Mason.
is greater than 15.
Is that the greater than?
But less than 15. Times
B
B
is less than 5
times
15. Good. Can you pause? We have to figure out how high we're coloring the thermometer. Okay?
18.
Good job. You beat me to it. High five. Well, okay. I was going to say 3 times 6 equals what? 18. So then go ahead and color the thermometer up to 18 degrees Celsius.
I was going to say
There are plenty of blues in here. No growling necessary. 3 times 6 up here.
mine is broken because it is gray.
It's just in black and white. It's a classic.
What I have.
All right. So everybody wrote 3 times 6 equals 18 at the top. David?
Yes.
At the top, 3 times 6 equals 18. At the bottom, we need to use our greater than or less than symbol. Which one is greater, 0 degrees Celsius or 18 degrees
18.
Celsius?
18.
Correct, yes.
18.
Excuse me. All right. Multiply. Composite numbers have more than 2 factors. So we have 1 times 20 equals 20, and 2 times 10 equals what? 20. And 4 times 5 equals 20. So do you see how we have all these different factors that can equal 20? So 20 is a composite number. Here we are. 1 times 20 equals 20. 2 times 10 equals
20.
Yep.
20. They all equal 20.
Well, the bottom ones, yes. Yeah, because we're multiplying 2 negatives. And when we multiply 2 negatives, we get a positive. Yep, it is. All right, let's look at our factor trees. Prime numbers.
Those trees don't look like that.
No, these are factor trees. We're going to say what numbers multiply to equal the number on top. Prime numbers, you remember we talked about yesterday. Prime numbers only have the factors of 1 and itself. So these numbers 16, 23. The only factors that you can multiply to get these numbers are 1 and itself. That's why they're prime. Okay? Next, we're going to look at our set of equations, or operations, equations. And we are going to circle, no, we have one more after. Circle the greatest common factor. So they started it for you. What number is the greatest common factor? 3. Why is 3 the greatest common factor if I see a 7? Because it's the common one, right? 3 is the only one. 3 is the only one that shows up in all of them, right? Can you finish circling all your 3's, please? And then next to where it says GCF, that means greatest common factor, we're going to write 3. Right here, Mason. All right. You're going to trace your conversions or your equivalencies. What does M stand for? Meter. 1 meter equals what? 100. Nope. 1 meter equals 100 centimeters. And 1,000 meters equals what?
1 km.
What is km?
Kilometer.
Kilometer. Good job. All right, last page. Flip to 8. And go ahead and trace your vectors for me.
Mom, is there going to be a vector B?
I don't know. Trace your vectors. You want to finish. Focus. You don't want to finish. You want to do math forever.
Are we going to finish the book today?
No.
No, Friday. If you actually don't. Saturday.
Yes.
Maybe someone having a breakfast with
Let's talk about our personal life after we're done with math and recording. Did you finish all of your vectors? No.
How does Dad write this?
All right. You're going to trace your limit. How do we read it? The limit of f of x times g of x as x. Good job. All right. On our pyramid, underneath our limit, yep. But you have to trace the difference between solid and dotted. What does solid mean? The solid line means the surface is included, right? The dotted. What? Sure. The dotted line means the surface is excluded, not included, right? Does that make sense? So, what does solid mean? Included or excluded? The solid line means included. What's the dotted line mean? Alright, let's trace the next thing. It's called, alright, stop with the crayons, pick up your pencil, and trace the next part, please. This is read as x approaches negative 123 from the positive direction. X approaches negative 123. Please go in order because otherwise your brain's going to be confused. We want to train your brain right, yeah? From the positive direction. Inequalities and equalities. Here we have line segments AB is 200 centimeters and BC is 200 centimeters, which means it's about equal to line segment AC, which is 400 centimeters.
I have a question.
Uh-huh.
How does infinity go in? Is this going down?
always do one more. They don't have a limit. They never stop.
That is a good reason.
Think of the smallest number you can.
0.
All right, what about negative 1? Is that smaller?
Yes.
What about negative 2? Is that smaller? What about negative 999,999,999? Is that smaller? You can always go one more. Does it break your brain?
Yeah.
Kind of. All right, so here we see 2m for the line AB is equal to m line AC. What's m here?
I don't know.
The other ones are centimeters, which makes sense because it's labeled centimeters. Maybe
Mom,
that's
is this
just that.
going this way? Is that less than or greater than?
That's less than. Whichever side is on the left is what, like you know how you read a word left to right?
Yeah.
Whichever one side starts on the left is what its name is. So if it's the smaller one, it's less than. If it's the bigger one, it's greater than. Okay, 2 times 200 centimeters is equal to 400 centimeters. Nope, we're only doing equal or about equal.
Maybe it should be about.
Let me double check. Yeah, they're all equals. Because here you have, come on Luna. Okay, so here you have 2 times 200. What is 2 times 200? 400, so those are the same. And here you have 2AB, which is, how long is 2AB? 200. So 1AB is 200, so 2 of them would be 400. So that's equal to AC, which is 400. All right, we're going to round. Our last thing is rounding to 0 or 10. Do you remember how we round? What's our cutoff?
Oops.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, so we are going to round either to 0 or to 10. Our cutoff is right here. If it's 5 or greater, we go up to 10. If it's 4 or lower, we go down to 0. Okay? So the first thing we see is 4. Do we go up or down?
Down.
Down to 0. 3. Do we round up or down?
Down.
Down. 3 goes down to 0.
No, Mason.
3 goes down to 0. You got this backward, baby. 3. Look at our cutoff, Mason. Where is 3? It's right here. So do we go up or down?
Yeah.
Down. So we go down to 0.
Can I trust my own?
No, sir. Where is 6? Look at your chart. Yes, you do have an eyelash in there. No, it escaped.
Stop blinking.
Come here. Okay. Do you want to go to the bathroom and get it out?
Okay. After.
Okay. Mason, look at your hill. Is 6 closer to 10? Or is it closer to 0? Which side is it on? 10. Yep. Look at your hill.
Is 9 close?
Yep. With, okay, so fill in your rounding hill. 3, 4. It says 5 or more, let it soar. Okay, so is this 5 or more?
That is 5.
That is 5.
To 10.
We go up to 10. What's this? Is it 5 or more? We go up. Yep.
Well, not put it flat, put it in there.
So now the trick is that we're only looking at the ones place. So now
It's 0.
1 is closer to 0, so we go back down to 10, right? 2 is closer to 0, so we go back down to 10.